These notes are over power. These notes are over power, and so you get more powerful by doing work quickly. Okay, so the equation that we'll be using for power is work over time, change in time. Okay, and power is measured in watts. One thing, too, I just want to note from the previous section, remember that work is equal to a change in energy. Okay, and then we have the equation work equals the applied force times the displacement cosine of theta, where theta is the angle from which the displacement is going. Okay, so breaking down the unit of watts, 1 watt equals 1 joule per second. Which computes to 1 watt equals 1 kilogram per meter squared divided by seconds cubed. Okay, so starting with our first example, you are at the gym doing squats. You raise a 92 kilogram barbell at a constant speed for 4.2 seconds through 0.68 meters. Okay, so it wants to know what is our power. It gave us a mass of 92 kilograms. The time it took us was 4.2 seconds, and the displacement was 0.68 meters. Okay, and if we were drawing the free body diagram, okay, gravity would be working in this direction. If we're squatting, we're going to be lifting it in this direction. So this would be our applied force working in the same direction as the displacement. Okay, so power equals work divided by delta T. Okay, plug in the equation for work. So power equals F of A times delta D times cosine of theta divided by our change in time. Okay, so because we are raising the barbell at a constant speed, F of A is going to equal F of G, just in the opposite direction. So to find F of G, remember, we would take the mass times gravity. Okay, so we can kind of just plug that into our equation. So 92 times 9.8 gives us the F of A. Our delta D is 0.68, okay, times the cosine. And because displacement is in the same direction, it's going to be cosine of angle 0 divided by our time, which was 4.2 seconds. And we'll find that our power is equal to 145.97 watts. For this following problem, you and your friend, and you can decide who your friend is. I'm going to pick Mickey. Decide to test who is more powerful. You each push a 85 kilogram tackle sled through a straight line distance of 100 meters. You apply a constant force of 250 newtons and it takes you 4 minutes. Your friend applies a constant force of 325 newtons and takes 5.5 minutes. Compare the work and power done by you and your friend. Okay. So real quick, I'm going to change my time into seconds. So I have 4 minutes divided by, I'd be multiplying. There's 60 seconds in 1 minute. Okay, which will give me 240 seconds. And then for my friend's time, I will get 330 seconds. Okay, so for me, my power is going to equal f of a delta d cosine of theta over delta t. So plug in the information. My force that I applied was 250 newtons. The displacement was 100 meters. Okay, and then I'm pushing it in the same direction as the displacement divided by the time. Mine was 4 minutes or 240 seconds. Okay, for the top part, I'll find that it is 25,000. Okay, that was the work divided by my time. Okay, so this is the work, which it did ask us to find to compare the work and the power. And then, so my power, whenever I divide it by the time, is 104.2 watts. Okay, for my friend, Mickey, we're going to use the same formula. The force that they used was 325 newtons times the distance. They're going to be pushing in the same direction as the displacement divided by their time, which was 330. Okay, so first just finding the work. So multiplying the top portion, we'll get 32,500 joules divided by 330. Okay, so this is our work. And then when we divide, we'll get that the power was 98.5 watts. Okay, so that's our power. Okay, so when we compare, I did less work, but had more power because I applied less force, but it took me less time. Okay, Mickey did more work, but had less power because it took them longer to complete the task. Okay, so Mickey might have had more frictional force working against them. This last example, a desktop computer has a power rating of 400 watts. If it is left on for 1 day, how much energy did it use? Okay, remember we talked about work is change in energy, so we can substitute that in for work in our equation. Okay, so it told us a power rating, so power is 400 watts. Okay, and it wants to know the time frame of 1 day. Okay, so delta T equals 1 day, which convert that, and we'll get, there's 24 hours in 1 day, and there's 3,600 seconds in 1 hour. So we'll get that delta T is 86,400 seconds. Okay, and it wants to know what is the change in energy. Okay, so power equals, usually it's work, but work, remember, can just be change in energy divided by change in time. Okay, and so if I rearrange this to solve for energy, I would have P times delta T equals change in energy. So just plug in my information. I have 400 times my time, which is 86,400. And I get that my delta E is 34,560,000 joules of energy. I just want to talk about some of your practice problems that you're going to have. the first one should be pretty simple. You can just follow along with the practice problems that we did before. I do just want to talk about the question number 2. Okay, so here they're giving you a starting velocity, okay, because from rest, this would be our V1, and they're giving us a final velocity, which you do have to convert into meters per second, so this would be our V2, okay, and then they also give us a time, right, this is our delta T, and then they also give us a mass here. Okay, and it's wanting us to figure out what is the power. Okay, so remember, power is work over delta T. Okay, so if we were to plug in for work, we have the applied force times delta D cosine of theta over delta T. Okay, but they don't just give us f of a and they don't just give us delta D. Okay, so remember that force is equal to mass times acceleration. Okay, where acceleration is going to be V2 minus V1 over change in time. Okay, so you'll have to plug in the mass they gave you and then the two velocities divided by the time given in order to find the force. Okay, and then for delta D, remember that velocity is change in or velocity is calculated by distance over time or displacement over time. Okay, so if I rearrange that equation, I will get the average velocity, so velocity times delta T, okay, where my velocity is going to be average velocity, so V1 plus V2 over 2 times my delta T. Okay, so you first have to calculate the F and the delta D before you plug them into this equation. Okay, cosine the angle is going to be in the same direction as the displacement, so it should be 0, cosine of 0. Okay, and they already gave you delta T. So that's just to kind of help you with that problem, setting up that problem. Okay, for question number 3, you will have to calculate your distance, your displacement, because they give you a starting point and an ending point. So you'll have to subtract to find the total displacement. And then again, just make sure that your units are correct because here they tell you it's 10 hours. Make sure it's in seconds. Okay, you guys do not have to do question number 4. We'll kind of go over that together a bit later.